Welcome to my presentation on PDDL templating and custom reporting. My name is Gregory. I'm working at Schlumberger Cambridge Research, and this presentation is for the KEPS workshop in ICAPS 2020. I'm on the right hand side of the photo. Let's start by looking at what we might see in the academic world as the traditional planning workflow. We have a domain and a problem, they get fed into a planner, which produces a plan. Traditionally, the domain and problem are authored using some text editor, and traditionally, because the plan is normally just part of our academic research, after it's produced it just ends up going in the trash can. In business, of course, we want to consume information from several different business systems, so different types of data sources, SQL, Excel, linked databases, or programmatically. And then once we have our problems and domains, when we have produced a plan, we need to report those back to users somehow. So either we store them in a database or we create some kind of reports. Existing work has focused on the task of domain and problem creation. For example, the GPO system, It's Simple, and the Visual Studio Code extension. This work takes a slightly different angle and is looking at how we can consume information from business systems to more quickly develop our planning problem and keep it closer to the data that we're consuming. Where this work differs from most previous work is that we're looking at how to create quick and easy custom reports based on the plans that our planner outputs. Before moving on to the details, however, I'd like to give a short introduction to Jinja templating, which is key to this work. What we have here is a JSON object. In this case, it's a list of people with the pet that they own. Underneath that is a small program called a Jinja template that transforms the data into some text. In this example, we simply list which pet each of the people owns. This slightly more complex example demonstrates the use of filters in Jinja. A filter is simply a function. For example, we have the select attribute filter here, we have the length filter, and we have a map filter, which is a higher order filter. The main contributions of this work are a combined JSON representation of a planning domain, problem, and plan, and the contribution of several useful Jinja filters for doing convenient computation on that data structure. This presentation will use a running example of the satellite domain, in which a number of satellites have to take various types of images of different interstellar phenomena. I'll now dive straight in and show how we can easily construct a satellite problem based on Excel data. This shows a problem file template for the satellite domain. In it we have several Jinja filters: Excel objects, Excel predicates, Excel functions, and Excel table. Note that we reference variables such as satellite instrument mode direction and Excel URL. These correspond to either URLs, this is a location of an Excel file, or ranges. These are ranges within the worksheet of that Excel file. How do these correspond to objects, predicates, and functions? Well, consider this fragment of a spreadsheet we can see at the top right hand corner. Column B lists all of the satellite names. We can use our Excel objects filter to create a list of objects with the type satellite, and the list is taken from the range. Correspondingly, the two columns B and C are the arguments for the initial state for the pointing predicate. So we can take any tabular data and convert it into an initial state set of predicates. We can also do this for functions. Now let's shift our attention from problem generation to plan reporting. Consider the following satellite plan. In isolation, the plan tells us what we need to do to achieve our goals. However, a user might have other questions to ask of the planner. Therefore, to provide answers to the queries required in reporting, we need to combine the information from the domain, problem, and plan. This can be seen conceptually in this schematic diagram. We first want to combine the PDDL domain, problem, and plan file along with a data payload. You see an example of that with the Excel spreadsheet data into one representation that will be fed along with a report template and some custom Jinja filters that help us to manipulate the planning data to create a custom report. What we've seen so far in this presentation is this first part of the process, where we're taking data sources, using them to create domains and problems via Jinja templates, and then we form a plan through a planner. If we lift all of this up, then the next part is to take that plan and either inject the information back into a database, create a web dashboard, or a LaTeX report or something like that. But what we need to do is combine the information from the domain and the problem and the plan in order to do this. So now let's take a closer look at this combined JSON representation. Here we have a high-level view of the combined JSON representation. You can see we have fields for the domain and problem, plan, we've got intervals, function variables, and a payload. Here we see a generic plan viewer that displays a plan report showing a Gantt chart view of the entire plan, showing the predicate timelines that we just showed. Where a predicate timeline is in green, this means that the predicate is a goal predicate, making it easy to see when each of the goals was satisfied in the plan. Underneath, we have graphs of the value of each fluent over time. In addition to this, this is actually an interactive report. So if I simply want to know the activities for satellite 1, I can filter by satellite 1, and now I only have the action timeline and the predicate timelines that mention satellite 1. Having this domain-independent viewer is certainly useful and definitely better than looking at the textual representation of a plan. However, part of the power of the templating system is that we can do domain-dependent visualizations as well, which is what we'll see next. This mission control planner view shows the plans in a step-by-step form for each satellite. There's an icon for every different action type. We've got a clock on the right-hand side showing the time in clock time. And each of the actions is displayed in a human-readable form rather than the PDDL form. If we scroll down, we can see the activities of each of the planner. It's a much more readable form than even the domain-independent form that we just saw. This is the end of the presentation, and I hope I've convinced you that templating is a productive way of creating PDDL and also a way of interpreting plans. There's many other examples in the paper, so please go and read that, and please get in touch if you're interested in this technology. Thank you very much.